All right, all set.
Okay, you're recording, Julia?
Yep, all good.
Okay. Hi, everyone. This is our monthly CNCF meetup. Although the slide below says 2019 Cloud Native, but we promise we are not traveling back in time, or we have not traveled back in time. We just forgot to update that. Today's agenda is I'll introduce the event. Then CNCF team, this organizing team, today's speakers. We'll do some housekeeping. Then our first talk by Ricardo, and second, he's from Elastic. And the second talk is by Anthony. He's one of us. He organizes the meetups too, and he's presenting this time. He's on the other side this time. So, and we have some cool prizes for which are both from our sponsors, and if you fill out our what is it, Julia? Our surveys. Okay, sorry. Um, so as you have already verified, the first one, the horrible host, which is myself, and and the others are Joanne, Julia, and Alex. This is our team of organizers. Archie is kind of holds the baton for leading the team. He's a great guy, and everyone else is too. Thank you for.
Can I just do one quick shout out there? I just want to say hey to Mike Foster. We put a little star beside your name. He's our newest member of the organizing committee for our meetup. So we just wanted to do a little shout out to welcome you. Super excited. Mike and I used to work together, and now we get to work here together, which is super fun. So happy to have you, and looking forward to having you on the team. Thanks for joining.
Now I finally know what the meaning of that star is. Like, I was trying to figure it out. Anyway, so thank you, Elastic, for sponsoring us, and also we have a great talk today from Elastic. Our new sponsor is JFrog. They are our new gold sponsors. Today's speakers, the CNCF updates would be done by one of us in the organizing team. Probably, I think it's Alex who is doing that. Then we have our first speaker, Ricardo. He's a principal developer and advocate at Elastic. Looks pretty cool in that picture, and his talk would be cool too, I'm sure. Anthony, he's a software developer at Adaptive. He's our second speaker today. And moving along, doing some housekeeping. Oh, please follow us. We do need followers. Like we do great work, and so keep guys over here. Whoever is listening us, please follow us in LinkedIn, Twitter. We are late posters, but we do post once in a while, so that's good. And follow us in Slack. That's the most active place for us. We are always. So this is our links. Feel free to grab a screenshot and email us if you want to present something, be a speaker. We are happy to have you on board. Sponsor announcement. Oh, so JFrog, like I already said, Jay.
We'll
you want to take this
here for Laurie maybe. So she's just joined as well. So we'll let team at JFrog make a quick announcement. I'm actually very happy to have JFrog back. JFrog was our sponsor for many years, and we're happy that they're renewing, especially in these difficult times where we don't have on-site events. So we're happy to have this partnership with JFrog again. And today I think we have Laurie. She wants to quickly make a quick announcement about their upcoming event.
Thank you so much, and thanks for having us again. We know that, again, in these trying times, community is the one thing that keeps us all going. I'm loving the virtual check-ins to make sure everybody's okay, and so now we're going to check in with you and let you know about our conference, which is called Swamp Up. As you see, Archie is one of our featured speakers. We've got Sasha and Steven and a whole lineup of other amazing speakers, and it's May 25th through the 27th. If you know a little bit about JFrog, our flagship product is Artifactory, but we have an entire CI/CD platform now called the JFrog platform that we'd love for you guys to try free. So if you go to our website, jfrog.com, you can try it for free. But in addition to trying our platform out, we want to give you a ticket to our tutorial day. So the tutorial day is May 27th. So the conference itself is free, but the tutorial day is an added bonus. It's $49, but we want to give it to you for free because we are super excited to share all of these great things that are happening. So I'm going to drop in this chat room how to get your free tutorial day. And I hope that that's not against any kind of procedures, but I feel like it's the easiest way. So you can either scan the link on your screen or just follow these steps that I just put in there. So you get a free conference ticket, a free tutorial day, go see Archie, Sasha, Stephen, and all the other amazing speakers speak. I'll be in the chat room telling jokes. I will not get lost in the chat room there. And yeah, I'm not Ari. He has a much better pitch. I'm just happy to be here to step in for him. And if you have any questions, you can follow me on Twitter, Lori LaRusso. I'll put it up in the little feed, but if not, I'm happy to hand it back over to the amazing organizers to do your thing and kick your sessions off.
Thanks, Lori. Say hi to Baruch. We all miss him as well. And also want to say thank you for post-event survey gifts that JFrog sponsored today. So we're happy to be working with you guys again. So 2021 and 2022 together. Thanks a lot. Suvar, you want to take back?
Okay. Thank you, Archie. Thank you, Laurie. So CNCF announcements. Alex.
Yeah. A lot of exciting things are happening in the CNCF landscape. Next slide, please. Yeah, we're starting with KubeCon. It's actually happening next week. KubeCon, Cloud Native Con Europe. It will be a virtual event, of course, and registration is still open. So if you don't mind starting your day early, you can actually attend some talks while having your morning coffee. The CFP for KubeCon North America, which will be happening in October, is open until May 23rd. If you're thinking about submitting anything to the CFP, we'll be glad to help you review your proposals and help you get a speaking slot at one of our upcoming meetups for you to practice, because newcomers and local members are always privileged. Next slide, please. Emissary Ingress. Yeah, this one, I'm super excited about this announcement. Emissary is, of course, a project from Ambassador Labs where I work. And it is the latest project that's been introduced into CNCF incubation. If the Emissary Ingress name sounds kind of new, don't worry. It's actually the existing Kubernetes native Ambassador API gateway that was built on Envoy, and it's just been rebranded. An Emissary is just another type of Ambassador. So we had to rebrand it for the occasion. Personally, I've been involved with the Ambassador API Gateway project since 2018. And when I joined Ambassador Lab in 2019 to collaborate full-time on other Ambassador projects. So to me, this is super heartwarming and quite an achievement from our team to see our efforts pay off like this. It's actually our second project that we've donated to the CNCF. The other one was Telepresence, which happened a few years ago. And some of you might actually remember, I think it was the very first Kubernetes meetup in Montreal, where we had Richard present talk about Telepresence. It was a meetup I think a lot of us still remember to this day. And joining the CNCF, this will ensure that the Emissary Ingress project will remain open source over time. And we will see also open governance of the project, starting with regular community meetings. We are super excited for what's to come with Emissary and Ambassador Labs, and we're actually hosting our very own little Ambassador Fest, which will be running in parallel to KubeCon next week, and it's free for everybody to join. So come and say hi. And also, we're hiring, so if you're looking for a new job working in open source, reach out.
Alex, why the name was changed? Ambassador was the cool name, I think. I liked it.
It was a very cool name, but for a lot of, I think it's only legal reasons, because whenever a project gets donated to the CNCF owns that trademark. And since, well, everything at Ambassador Labs is called Ambassador, we would have needed to give the entire branding of the company to CNCF, and that was just logistically too complicated. So rebranding the project was the simpler approach.
Congrats to Ambassador Labs, and very excited to have Emissary Ingress incubated now.
Yep, me too. Right.
And hopefully you guys maybe have a presentation one day, tech talk or something. We would love to learn what happened since a while in the project.
Yeah, I think we're overdue for a tech talk. Yeah. All right, next slide, please. Kubernetes 1.21 was released. Name tag or code name power to the community. It saw a bunch of new features moving to stable, like cron jobs and immutable secrets and config maps, and a lot of enhancements moving it to beta or alpha stage. And something we haven't seen a lot in the Kubernetes API lifecycle yet is the deprecation of some features, including the pod security policy and the topology keys, which will get replacement in the upcoming versions. Next slide, please. And finally, one enhancement that's not actually part of the release, but that will change things a lot in the community, is the release cadence for Kubernetes. So the project is moving to 3 releases a year instead of 4. This is in hopes that it will make it easier for the various Kubernetes distributions to just keep up with the release cadence, and hopefully get everybody on more stable and up-to-date versions. Special shout out to Dahanne, one of our Canadian community members, who's actually been selected on the 1.22 release team. So we wish him luck. All right.
Okay.
Thank you.
Well, thank you, Alex. Today's first speaker, Ricardo. I will hand over the controls to him now. Welcome, Ricardo, and thank you so much for being with us today.
All right, thank you too. Let me start sharing my screen here, and then let's get down to the thing called observability, right? I'm going to share my entire screen because I'll keep changing tabs all over the place. So let me just know if we are ready to rock. Can you see, right?
I see your screen.
Can't see your screen.
Can or cannot?
Cannot.
Cannot.
Oh, cannot. Okay, that's weird. All right. Let me cancel it. Share entire screen. This screen. Oh, that's because I have 2 monitors and I haven't selected the exact monitor I want to share. All right.
Okay,
welcome, everyone. Thank everybody for being here. And most importantly, thanks for the CNCF for the opportunity to be speaking here today. I'm going to talk about myself in a minute, but let me just emphasize what is going to be the plan for this talk, right? This is going to be one of those talks where we emphasize in the journey to achieve something, right? So I'm not going to spend like any slides. Actually, there will be no slides in this presentation, only the ones to set a context. And I'm not going to focus on the observability part that, oh, observability is all about the 3 pillars and all of that. I'm pretty sure that everybody have heard this story before. And what I'm actually going to emphasize here in this talk is the journey that people have to undergo to actually achieve some of the benefits from observability, which I think as a developer and as someone that actually had undergo this journey before, which matters for our daily jobs, right? So first of all, for those of you that don't know me, my name is Ricardo Ferreira. I am a developer advocate. I like to explain that my job is basically I'm a content router. Like I basically connect people with content, right? Regardless of what type of content that is. I'm part of the Elastic community team. This is what I work for. And this year, I also start being a HashiCorp ambassador, specifically focused on Terraform. So if you ever you like this technology or you want to talk about this more, I'm supposed to know a little bit about this, and I can share some of the things about with you as well. And before Elastic, I used to work for other vendors as well. So some people might know me in the community for the work that I've done regarding Apache Kafka, right? Because I used to work for Confluent before, and but pretty much what I talk or demo or play with these days is technologies related to this: streaming data, big data, analytics, and cloud, right? So this is the subjects that are, if you start talking with me, I'm gonna be way more than happy to talk about it, right? Among other things as well. And if you want to get in touch, those are my emails: Ricardo Elastic, Ricardo Ferreira, and in Twitter, I'm also at Ferreira. So I'm easy to find, all right? So the point here of this presentation, as I mentioned before, is to emphasize the journey to achieve observability. And part of this journey is to make sure people don't fly blind, right? I think that's the worst part of working with IT these days, right? And a distributed nature of the technology that we have, it is very uncomfortable for people to actually fly blind when they are operating systems. And observability seems to be a thing that aims to solve that, right? And pretty much every time people talk about observability, they jump straight to this, right? Nice storyline diagrams that show all the traces, and you can easily spot what is the bottleneck or the source of slowness of a given transaction, things like this. And make no mistake, we are going to achieve this here today. But like I mentioned before, I'm going to focus on the journey, right? And the way I found to actually create this is let's start with an example, right? So I brought you here an application that it is available on the GitHub. I'm going to provide a link in a minute, but you can clone the repo, you can play with, and everything is kind of a very simple to use. It's all Docker-based, so just spin up the Docker container so you are ready to go. And this application basically has 3 microservices, right? There's the front-end layer that has been written using Node.js and the React framework. There is a back-end layer that has been written in Java, and it uses Spring Framework as the implementation for handling dependencies and talk with the databases. This framework in Java talks with a database and also talks with another microservice that is written in Go. And this Go microservice in turn talks with Redis database. So as you can see here, it is a typical distributed architecture that by the time you start seeing that this implementation is not working as appropriately, you're probably going to have a lot of trouble to identify source of slowness, bottlenecks, and things like this. And that's where observability comes into play, right? But again, observability is not just about the tooling, right? You can install whatever backend observability you wanted, like Elastic APM, Zipkin, Jaeger, or any others. But they are not going to mean much if your applications are not instrumented properly to create and send this telemetry data to this backend for visualization and monitoring purposes, right? So this is what we are going to try to achieve here today. All right. So this is the application. So let me start doing some cleanup housing. First of all, let me share the URL of this GitHub repo here. Probably I can have access to the chat. Yes, I can have it. So I'm going to put here on the chat. Just one heads up about this repo here. If you go to the master branch, you're going to see that all the code still use the Elastic APM API for do all the instrumentation and everything that has to do with the observability. However, in the last days, I've created a new branch that I've called Open Telemetry, right? And this is what I'm going to focus here today. In this branch, you have the code that I'm going to show here today. And It replaced the specific usage of the Alask APM API, and I'm going to do everything using OpenTelemetry, right? Which is pretty much the future of how applications are going to create and send telemetry data, right? So I think that's the part that's interesting. So just keep that in mind. When you clone the REPL, make sure to use the branch OpenTelemetry, because that's where the cool stuff resides. I plan to finish up some changes that I still need to do in the code, and then I will submit this to the master branch, probably this week, right? Okay, so what I have here, and this is the code that I have from the clone that I have on GitHub. This is this Docker Compose file. Pretty much the first thing you need to do in order to try out this code is to spin up the backend servers. So this is going to spin up one Redis server. This is going to spin up an APM server. Like I mentioned before, since we are using OpenTelemetry here, you can use whatever backend you wanted, right? Just make sure to replace the endpoints in the code that I'm going to show here later. But in this example, I'm going to use Alask APM, right? They are running, I think. Let me just double check this because this is really important. So if Redis is up, Docker PSA, yeah, everybody's running, and Redis is probably up as well. Keys, all right. So because I need some data on Redis be available so my Golang microservice actually works. If everybody is actually running, so let's start talking about the example. So let's talk about the backend Go. I'm going to spin up everybody at this point so we can see the application running before the actual instrumentation, right? There's a script called run locally that you can just execute to bootstrap each microservice. And there's one. Okay, so Spring Boot is up. Is it up? Yep, it is up. And there is the front end React where I need to spin up as well so we can start playing with the application. So what we're going to do here today is this application has intentionally a bug, right, that I've created in the application. And I'm going to put this application in this window over here where you can see it. Yep, you can see it. And this application, basically what it does is to allow users to create and register cars, right? So let's make an example here. Like let's create a task car. Model is going to be task, car black, year 2021, and the price is going to be $5,000. So if you click save, this is basically going to, this is the front end layer, right? So basically what this application did was this. The front end called the backend Java, which creates an entry in the database. But before creating an entry in the database, it communicated with the backend in Go to make something called calculate estimate, which is this field over here. Kind of calculate the market value of this car, right? Giving a set of parameters, the brand, the price, the year, et cetera, right? So there is a direct communication between the Java microservice and the Go microservice. And basically what the Go microservice does is to query all this market data information in this Redis database over here. So as I mentioned before, it is a distributed transaction by itself, right? What important is, apparently, the application is working as expected, right? Because we were able to actually create a new car. However, let's simulate, right, the bug that someone from the users team actually related and reported. Let's pretend they submit an issue on GitHub saying, hey, by the time I was trying to create a car that was a Ferrari, let's put a Ferrari here. A Ferrari needs to be usually red. So look what happens when I click save, right? So instead of instantly like create the car, so it's going to take like some time. Eventually, the Ferrari went Go, but you can see that there is some slowness, right, in the process. And this is the part where, okay, I have a ticket here. I'm from the ops team, and I have a ticket here, and I want to identify where was this slowness, right? However, this is a distributed architecture, so I have no idea where to start. It could be in the front-end layer. It could be in a Java microservice. It could be in a database. Could be in Go. Could be in Redis. So this is the part where, okay, I have watched some presentations like that. People say that if I use observability, I'm going to solve all my problems. So how do I get from here, right? I have the problem in front of me, and to start using these amazing observability tools that people say that are all shiny and cool things. And that's the part that I think is important for people to understand the journey, right? You're going to see the changes that I'm going to make in these microservices. And the idea of this talk, right? Obviously, I'm gonna be able to achieve this, right? You're gonna see the end result in the end. But the idea is for you to feel, right, what you actually need to do to achieve something. And specifically, if you are using the framework OpenTelemetry, which is, as you may know, just to set a context here for those of you that don't know, OpenTelemetry is a open source and standard-based specification that dictates how applications can collect metrics. We call those telemetry data, right? And you can export them into a common format that any backend compatible with OpenTelemetry can receive, process, and store. And therefore, they're able to do the shiny stuff that you were looking here in the slide, which is plot them, and you can visualize things, and perhaps some implementation have some machine learning features that can periodically learn about some outliers and things like that. But the point is, the journey before that, actually, it is the part that for us, technologists, I think is important, right? So let's start bringing observability to this problem, all right? So I'm going to start by explaining something very, very important, right? I'm not sure how many of you have heard this term. I'm actually going to open the chat here. So give me a thumbs up or thumbs down if you ever have heard the terms white instrumentation, white box instrumentation and black box instrumentation. How many of you have heard about these terms before? Two thumbs up at this point, right? 3. All right, cool. So what I'm about to show you, okay, 1 thumbs down. All right. Thank you, Anthony, for being honest. So the 2 microservices that I'm going to change, I'm going to exercise the 2 of them, right? The first one is going to be the Java microservice. And for the Java microservice, I'm going to apply the technique of black box instrumentation, right? And by understanding what the black box instrumentation does, you are going to see what are the consequences of having to do white box instrumentation, right? So let's start with the Java part. So the Java is running on the second terminal, so I'm going to pause, right? This Java microservice, so whatever transaction goes right now is going to fail, and because the REST endpoint is not exposed. So let me show you what the actual script that I've executed before does, right? So this is a script that I've executed to start up my application. As I mentioned before, the application is written in Java and uses Spring Boot. So essentially what I do in this script over here is to export an environment variable that basically says where to find the endpoint for the Go microservice, right? And then I force a build, a fresh build of my code. And then I'm going to simply execute my application. Java minus jar, here's the jar file of the application. Very simple, pretty much what every Java developer do with their application, right? Okay. All right, Sebastian, you are going to understand what is the gun definition. This is how I am going to intentionally show this and practice, and then you are going to intuitively understand what the black box and white box means, right? So what I'm about to do right here is literally what we call a black box instrumentation, right? So we have the jar file. So this is the situation where, okay, I have access to the Java developers, but I am afraid to ask them to change their code, situation number 1, or I am actually not willing to ask the development team to change the code, and I have to do something kind of auto-magically to instrument this code, right? So this is what we are going to do. So I'm going to uncomment this part of the script that, as you can see here, basically is downloading something called OpenTelemetry agent, right? And the Java word, this is important. In the Java word, there is this agent that you can download from the OpenTelemetry project, right? And then I'm going to
we
have communication issues. Hopefully, we got speaker back on track. Is there any questions so far, or that's like in the middle of the demo? Maybe he shut down the. Let's hope he's gonna able to get back soon.
Yeah, but also there's something that happened because all the attendees all dropped off.
Oh, okay. Interesting.
Oh, what is that?
Everybody's coming back. Like the number of attendees is fluctuating. It's very strange.
Yeah. Wow. We never had this issue before. We're apologizing, and we're going to follow up with Bevy team. What happened?
On my side, Slack is very unresponsive as well. So it might be a cloud outage of some sort.
Interesting.
Who are they running on?
It goes up and down. The number is 32, 35.
Yeah, it's very strange. Let's see if he can join back. Otherwise, I'll send a quick message.
It's interesting. The host stayed, right? Majority. Or
I'm just gonna. Yeah.
If you look at the chat, Antonio says that he was sent to
I'm back.
Room.
Something happened globally. I think there was hiccup. So.
Oh, okay. Okay, no worries, no
We
worries.
can resume, but we have some people drop, but they're coming back as well. So seems like there was an outage somewhere.
Okay, do you want me to wait a little bit?
Yeah. Thanks, Ricardo.
Yeah, that's okay.
You see if there's any questions in the chat that you can start answering for now, or
not right now. I don't have any in the Q&A either. It looks like people were in a breakout room that will be closed. It's very strange. Thanks for the info, Adrian.
Yeah, that's what happened. I've been brought to a break room as well.
okay.
Very strange. Okay, I'm going to open a ticket with Bevy. Thanks for the info, everybody. So Ricardo, why don't you maybe keep going? I didn't stop the recording, so you can just carry on and
Okay,
we'll go from there.
All right, sharing again, and we were exactly right here. So I was at the point that I was uncommenting the code for the script that spin up the Java microservice, right? So I'm going to actually remove this part over here. I'm not going to execute the Java application like this anymore. So as you can see here, I'm downloading an agent from the OpenTelemetry project. And this agent is going to be available locally as this jar file. And this is the part where you have, this is OpenTelemetry specifics, right? So the way OpenTelemetry works, your application can communicate directly with a backend, right? Situation number one. If the backend understand a protocol called OTLP, right? That basically is a protocol on top of gRPC. It is a standard protocol. There are other protocols available, but this is the standard one, right? So this is option number one. If your backend does not support OTLP directly, there is a component in the OpenTelemetry project called a collector, right? So your application can point to the collector, and the collector is going to be responsible to ship the telemetry data to your backend, right? In this case, I'm going to point directly to my backend because it does support OTLP, right? Regardless, you need to provide what we call an exporter endpoint, okay? And this is my endpoint that in this case is pointing to Elastic APM. And the way in OpenTelemetry you specify this is using this environment variable over here, otel.exporter.otlp.endpoint. And you're going to provide here either, like I mentioned before, either the endpoint of your backend or the endpoint of your collector, all right? And then there's some metadata that you can set that basically is going to be used for how the backend is going to know your microservice. So this is the convention that OpenTelemetry adopted, right? And then as you can see here, basically I'm executing with the agent that I've downloaded, and then I'm providing some parameters and runtime, and that's it. The code itself remains the same. I don't need to do anything. So with that in mind, okay, I think my terminals went down or not. Oh no, they're still here. Good. So I just need to spin up again my Java microservice. So let's run one more time. But the point I'm trying to emphasize here is that I didn't change anything in the Java code, right? The jar file is the same. As you can see here, the script downloaded the agent from the OpenTelemetry, and it's basically jumping straight to execute the code as is, right, directly. What's happened behind the scenes is something that we call, in the Java word, dynamic bytecode instrumentation. That's a very beautiful and fancy name that if I ever have a second son, I'm going to name it dynamic instrumentation as well, because it's so beautiful. But what this name does is essentially dynamically insert code into the JVM that was not written originally by the development team, right? It is a code from OpenTelemetry that got injected as a bytecode into the JVM, right? So right now that our application is not only instrumented using the black box technique, let's create a new car, right? Let's call this test2 and save it, right? Oh, okay. I knew it that the application had to be restarted, because when the problem occurred, I had to restart everything in my environment. So let me just restart one more time my front end. Okay. This is the beauty of live demos, right? That's how people know. All right, test 2 actually went through. The application just needed to actually reload the endpoint that got replaced. But anyway, as you can see here, test 2 went through. So if we go to Alaska APM right now and go to the APM tab, we're going to be able to see that there is this microservice called backend Java, right? That currently is speaking to a database and coming from this address. And there is this transaction called /API/cars. And we can see, where is the post options? All right, this is the post, the request that went through to insert a new car. And then we can see that, like I mentioned before, automatically, right? Because of the OpenTelemetry instrumentation from the Java agent, right? The bytecode kind of detected all the frameworks and technology that were being used in the application, and it knew, right, and automatically discovered everything and stitched everything together, right? So back to the question, just a heads up, there is a countdown here saying that the breakout rooms are going to start in 3 minutes. I think that's the same problem that happened before. Should I continue?
I'm gonna say yes. I've never seen this before. I don't know. I'm gonna see if I can close the breakout rooms. Just keep going, and please note, everybody, if something happens, please just come back and join us. We'll be here.
Which is pretty much what every technology does, right? When we have to restart something, right? We basically just Q -9 and then we put it back again. So that's the same thing. All right. So back to the question that I've made it before. We are calling this black box instrumentation because we are treating the application as a black box, a thing that we don't have access to or we don't know what entails it. And then we are instrumenting anyway, right? So this is usually the best thing that people would like to use, but unfortunately, black box instrumentation is not available for every programming language and every technology, at least for the OpenTelemetry project, right? So this is what you're going to see in the Go microservice right now, right? But the point is, right, back to the scenario, right? We are starting to have some visibility here, right? We have the visibility about everything that has to do with the Java microservice. But as I mentioned before, the transaction is not just the Java microservice. What about the Redis database? What about the Go microservice? We need to bring those in so we can start having full visibility, and then be able to identify the bottleneck, right? So let's start doing the same process for the Go microservice. So what I'm going to do now is stop the Go microservice. It has been stopped, right? And let's take a look on the script. Let me minimize this a bit. Let me ask you this, actually, a feedback. The font size that I'm using here on my IDE, it is okay for everybody to read? Let me see the chat. Okay, good.
It's readable.
Okay, I'm sorry. I should have asked this in the beginning. All right, so let's go to the microservice written in Go. And the first thing we're going to do is to, just like we did in the Java microservice, is to export a endpoint, right? So let's recap, because this understanding is important. In the OpenTelemetry world, this endpoint is going to be either the backend that are able to support OTLP protocol, which is the standard protocol for OpenTelemetry, or it's going to be the endpoint of a collector, right? Which is a component that you can download from the project, spin up. It is basically a Docker image, and then you can spin up and has many instances as you want it, put a load balancer on top of it, right? Et cetera, et cetera. But this is the endpoint that our microservice is going to communicate, right? Okay. First change. The second change we are going to do is actually in the code. And this is what we are calling a white box instrumentation, because we are going to literally make changes in the code directly to make sure that this Golang microservice is able to, via OpenTelemetry API, to use the endpoint that we've provided and send the telemetry data, right? So just a walkthrough in the current code. It is a simple main function that basically creates a connection with Redis, right? As you see here before, the Redis endpoint is passed as environment variable as well. So that's what the code is doing here. And then we are creating some, what we call, in the Go world at least, what we call HTTP muxers, right? We use some middleware like instrumentations to dynamically wrap and expose endpoints, right? So long story short, we are making all those functions here available over the port 88880, okay? So nothing fancy in there. Okay, so let's start the process of actually bringing observability to this code using OpenTelemetry, right? Here it is. You're going to see that differently from the Java world, the Go world. Here's the thing: the Go programming language doesn't have the concept of agent, right? At least an agent that can dynamically insert bytecode into the process, right? Why? First of all, because Golang is a native compiled language, right? So you cannot simply there is some techniques that you could use, like some shared libraries that you can dynamically insert code, but it still requires you to change the code. So that's why in Go, right, and probably in other programming languages as well, such as Python, I think C# using the same technique is going to have to do change in the code, right? So I'm going to actually put a session here that I'm going to call it OpenTelemetry configuration. And you're going to see that there is some substantial amount of code that we need to do. This is the code. I need to fix the imports as well. Okay. So basically the session that I've just added to the code is this, right? So it starts from here, right? And go until the part where the radius that was there already, right? Basically that. So let me just continue my timer. I'm not going to explain in full details all this code, but I'm going to give the high level, right? Because I don't expect everybody to, first of all, know code here in the session. And secondly, you don't need to understand Go specifically, right? But it is important for you to at least understand the high level thing that we are doing here. First of all, we are retrieving the endpoint from the environment variable and creating something that we call in the OpenTelemetry world an exporter, right? Then we are creating some labels. Remember the metadata that I've provided for Java I'm doing the same thing here. So I'm basically giving a name and a version of a microservice in form of labels and attaching this to the exporter. Then I'm creating something that the OpenTelemetry workshop calls BSP, or Batch Span Processor, right? Pretty much all the code that is executed in your application generates what we call spans, right? So we need a processor to batch those spans, right? And then prepare them for transmission. Because otherwise, if you don't batch them, for every single code executed, you are going to create a network HTTP call. Not necessarily HTTP, can be gRPC as well, but your application is going to continuously create network calls, right? And this can be expensive sometimes, and depending on the environment that we're working with. So using a batch span processor is usually a good idea in the OpenTelemetry world, right? And then, blah, 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 we are doing this. This is what matters. We are registering globally in the process of Go a tracer provider and a meter provider. Ricardo, why? Because from this point on, every other piece of the code, they can create programmatically traces and metrics, right? Using, of course, the OpenTelemetry API. And this is exactly what the code is already doing it, right? So, but what was missing is the part of the code that creates all this, let's call, link between your application and the endpoint, right? So the link has been created. So without further ado, let's just execute our Golang microservice one more time. So run locally. So it has been created. So for testing purposes, let's create a new car. Let's call test3. And if it works, we can simulate back the addition of the Ferrari. Page 2021, 5,000, save it. All right, so it went through. The fact that we have market data set here, it means that the Java microservice communicated successfully with Golang. So everything is working. Let's just see right now what has been, let me filter for the last 5 minutes. So there's one transaction here in the last 5 minutes. Hopefully it's going to be this one that we just executed. It didn't came through yet, so let's refresh one more time. We should have, let me click here on APM, and we should have a service map. Okay, so you're already detected there is a relationship between Java and Go. So that's good. Now let's inspect the transactions /API/cars. Oh, here we go. Okay, so probably is this one. This is a get, and this one is a post, this one. The overall transaction took 32 milliseconds, but now look at this. We can see that there are some Java and backend Golang being shown here, and visually we can see that, all right, in this transaction that took 32 milliseconds, right, pretty much all the time was spent on this save method here under Java, which is 29 milliseconds, because Go took 1.6 milliseconds to calculate the estimate. The Redis thing took microseconds of latency to execute, and then there was some communication with the database. So pretty much the overall latency has to do with the execution of the Java method called save, right? Which is pretty fast anyway. 32 milliseconds is pretty fast. Now that we have all the ingredients in place, let's simulate back the transaction that took a while to complete, which was the Ferrari. So let's try to add a Ferrari one more time. Ferrari. They need to be usually red, right? And then I'm going to click save. And then we can see that the problem is reproducible, which is a good thing in a world of technology, right? One of the worst problems that developers have is when people say that there is a problem and you cannot reproduce them, right? I think that's the worst, right? Give me a thumbs up on the chat if you agree with that, because not being able to reproduce is not very good. All right, the transaction went through. Now let's go back to our APM backend and see, first of all, let's see if there's a new transaction coming to play. So let's go back to transactions and then inspect this transaction over here. And in the last 5 minutes, we should have a transaction, here you go, that took 5 seconds, 5,031 milliseconds to be precise. And here's the part where if you have everything in place with your observability strategy, regardless of the backend that you are using, you can start collecting the fruits of your efforts, which is, all right, without thinking too much in this diagram over here, right? What was the layer and part of the transaction that actually was the offender in this transaction? We can obviously and visually eliminate Redis. Redis was pretty fast. The database took microseconds, was pretty fast as well. It worked on my computer. This is the famous, right? And then obviously the upper stream layers, they are going to forcibly took more time. But in the middle of this, here's how you see this. You go to the top and then you scroll down, 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 down. If you find your offender, the next one, if they are not including 5 seconds, so here are our offenses, calculate, estimate, right? And here's the part where it is interesting. Right off the bat, you know that because it's green, which microservice is this? Is Golang. So by all means, the slowness is not on the Java microservice. We can eliminate that layer already, right? So it is on the Golang part, and then you can see here on the metadata that basically, see here, the framework was collected. We can see that there was this function called calculate estimate. So here's the part, here's the heads up that the ops team can give to the development team, say, people responsible for the Go microservice, go to this function called calculate estimate and check what the code is doing, right? What it's doing specifically. And then let's do this. Let's do this exercise of, let's pretend we are the development team responsible for the Go. And then let's search for calculate estimate. Oh, here we go. So here's the function. So calculate estimate, right? And okay, so what the code is doing is to create a response object that we're going to be using later, right? And then is setting some spans here for Redis, blah, blah, blah. Basically is, let's inspect the code. The first thing is to try to retrieve the estimate from Redis here. So it's basically using a get on Redis. And it's trying to calculate. This is what it was shown. Here's a get. So that went through okay. And then if nothing is retrieved, it tries to calculate the basic price, which probably is not the case because I am pretty sure that the Redis database has a Ferrari. Keys get Ferrari. Yeah, so Ferrari's 2,500,000, right? So it was definitely was not the case because there was no need for execute this part of the code here. Let me minimize. So we can jump this, was not here. And then it calculates some markup. This is basically our arithmetic, our expression. It won't take long, right? Basically, it's going to burn some CPU cycles, but not that much. And then it's going to check whether this Ferrari, for those of you that don't know Redis, this function called sysmember, it basically checks whether a given element belongs to a set, right? So there's a set in Redis that basically what we call fancy cars. And let's face it, Ferrari, it is a fancy car. So in this call over here called sysmember, it's going to return true to this is exotic variable, right? So it's going to check, it is exotic. Yes, you're damn right it is. So it's going to calculate this additional markup. So you see that now that the development team has received the proper input from the ops team, they're able to pragmatically check the code. It's different to go to the development team and say, hey, go to this calculate estimate and see what's going on. How do I going to show what's going on if I don't know what car was sold? But now with OpenTelemetry, you can know this because OpenTelemetry supports what we call attributes. Every span created, you can attach attributes that aims to describe the transaction for the ops team. And here we go. This is the attribute that we're going to use it. And then if we finally go to this, where is the code? Here we go. Additional markup, what this code does. And here we go. This is the part. I'm going to look into the chat because everybody will kind of feel this. At least in Brazil, I'm from Brazil originally, and this is the part where we call this type of code here a dead body, right? So this is the part where someone had some brilliant idea to make this sleeps on the code. I don't know for what reason, and they forgot to remove this code that obviously doesn't do anything good, right? Rather than sleeping for 5 seconds, right? Regardless of the motivation for the developer to put this on the code, we just found the bottleneck, right? Obviously, this was just an exercise that was intentionally a sleep in the code, but it could be something else, right? It could be maybe this additional markup is performing a network call to another layer of the architecture, and perhaps it's taking too much long, and then we can inspect if this network communication is taking too much. Perhaps there's a firewall. Perhaps the firewall is having hiccups. You name it. There's a lot of reasons that could cause some slowness. But the point is, we were like a very chirurgically, specifically in the code, but thanks to the observability that was provided. But, and there is the bottom line, everybody, this was only possible because we were able to instrument the application properly, right? Either using black box instrumentation, either using white box instrumentation, right? And if there is something that I would like to, we're finishing up here, right? So we're basically wrapping up.
We would try to wrap up, Ricardo. Yeah.
Yeah, there's time, right? Yeah. No, we're done. We're done. Just one final message. That's just for you to get the sense of how much work you would have in an application to get actually observability up and running. So that's what I've tried to show here today. And thanks everybody for being with me so far.
Okay. Thank you, Ricardo. Well, now I know the reason for all my problems in my code. My code is sleeping. Damn.
Oh, yeah? Okay.
Yeah. Everyone, if you have any question, please post it on the chat, and Julia will take the questions. But right now, first we'll hand it over to Anthony, and so that he can, while people are asking questions, Anthony can present. Is that okay, Julia?
Yeah, I think that works. Ricardo, I just want to make sure you have access to the Q&A, because then you can just type your answer as opposed to doing them live, if that's all right.
Yes, and I do have access. I can see there's a question here, and I will answer here asynchronously.
Okay, cool. So if anyone wants to see the questions or ask Ricardo any questions, you can do it in the chat. And yay, Anthony. Thank you so much, Ricardo, for being here. That was super. The demos rule. Sorry we kicked you out and brought you back in.
No worries.
We're super happy to have you, and you too, Anthony, our beloved organizer, co-organizer. So I'll pass the floor to you.
Okay, I'm going to try to share my screen. All right, there we go. Can you see my screen? Fantastique. Bonjour à tous. Je parle ma langue primaire et le français, mais dans le contexte de CNCF Eastern Canada, je vais présenter aujourd'hui en anglais. J'espère que je ne vais pas trop faire mal à vos oreilles, à tous les francophones. Hello everybody. I'm going to present in English, even though my first language is French.
Anthony, peux-tu juste faire escape puis réouvrir pour moi? It's not presenting properly.
No, yeah, I could see that, I guess.
Just present again, yeah.
Better?
No.
Maybe
refresh the page.
I don't know. Let's just give it another shot. You know what? I'm going to present not full screen. Just gonna suck somehow, but it's better than nothing, right?
Idea, Anthony. Yeah. Just carry on like that. That's a good idea.
Sure. Yeah,
Or you can send me your the link and I can present them for you if you want.
Yeah, but I got a lot of demos.
Oh.
You know, I'm going to go back and forth. Anyways, yeah, let's go through with this. So the title of the presentation today is Java application containerized and deployed. But actually, I just crossed out Java because if this presentation, I already presented it at different conferences, but they were mainly developer focused. You know, so for the sake of CNCF Eastern Canada community, I didn't want to be specific to Java. But you know what? After watching Ricardo demo, I was like, oh wow, you know what? Java is kind of mainstream, right? Because most of his presentation was running on Spring Boot, so that's pretty cool because that was what I was using. Anyways, I'll try not to be too specific. And this is how I kind of work with presentation for the context of this meetup. So So first, who am I? I am Anthony. As you know, I'm already part of the organizing team of the CNCF Eastern Lab, and I'm also part of the organizer of the Montreal Java user group. And also, we have a sister organization, Raise and DevOps for Kids, where we run some events for kids, usually 3 times a year. But due to the pandemic, we didn't do much in 2020, and 2021 is not looking good either. But hopefully, we'll be able to resume our activities. So let's go to the content directly. What I'm going to talk about, of course, containerization. This is what Buildpacks are for. And first, we'll see very quickly how we used to do without Buildpacks and how we can do with Buildpacks. Notice my t-shirt. See, I'm definitely in sync with my clothing. I try to do that. Anyways, and then at the end of the day, does that make sense?
Sorry, Anthony, the slides are not changing. After you clicked on it, it's kind of stuck in between.
Okay.
How about you stop a couple of tabs? Maybe you have many tabs open, so.
But the thing is that I was just sharing my screen, right? So this is, yeah, let's resume from the beginning.
Maybe your RAM is full because of a lot of tabs.
If you know, Suro, I'm usually running many more tabs than this. So this is nice, and this sucks. Okay. What about I'm going to join from another browser? I hate doing this in the middle of something. Please wait for me. I'll be back from another.
Yeah, sure, no problem. Well, meanwhile, everyone, Archie, we can do this survey, right?
Yeah, I think that's a good idea. I'm gonna find the link and paste the link so people can.
If you can share over your slides with the link with the QR code, so people can scan it and start answering. And in the meantime, I also posted in the channel the post-event survey.
Yeah, Anthony, can you stop? Yeah, good. Yeah, I can share now.
All right, thanks, Subro. So today we actually organizing the post-event survey sponsored by JFrog, and they kindly providing us set of 5 t-shirts and Liquid Software book written by Jay Baruch. So we pretty much do as usual. Please fill out the survey, and we're gonna run the draw, and Ari from JFrog will contact the winners and send the prizes. So
I'm back.
Yay!
Yeah, so we'll do the draw at the end, but please use this time to fill up the survey, and we'll get ready for the draw.
Okay, is Anthony back?
Yes, I am. Can you hear me?
Yeah, we can. Yeah.
Oh, good, Anthony.
Okay, cool.
Yeah.
Let's see how it works better. Is it fine? Full screen? Yes, no?
Yeah, it's great. It's great.
Well,
Maybe try and change, flip between two slides. Like go to the next slide. Yeah,
Yep,
it's good.
you're
It's
all good.
awesome. Awesome.
wow. Okay. Sorry about this, Johan. Where was I? I was talking about that this talk is about containerization and not specific to Java. But Java is my favorite language, so probably the examples will be using Java. So yeah, we'll see what we used to do for containerization back in the days in 2014 versus what we can do with Buildpacks. So very quickly, what is containerization, by the way? So I usually say that it's a bunch of layers on top of a host kernel, right? So you've got your OS running, and your operating system is sharing its kernel, but that's about it. Then, thanks to containerization, we're able to package libraries, binaries, and also some metadata in an isolated way that could run directly as containers. So how did we perform isolation for containerization? Well, using 3 technologies that are super effective: chroots, namespaces, and cgroups. Thanks to namespaces, you can limit what the process running in the container can see, such as PIDs, network, file system, and so on. And versus cgroups, you can limit what you can use, such as the amount of memory, CPU, etc., that the process running inside the container wouldn't be allowed to use. So how would you containerize a Java application? And actually, that could work for Go, Python, Ruby application as well. Basically, the first way that we used to do in 2014 was simply using the Docker CLI, run the Docker daemon. And we would the developers just had to provide a Docker file that was specifying a base image, and then the developer would actually add as a layer, as one or several layers, the application, and then some metadata to instruct how this application can be run from inside the container. So here we're using the combination of an entry point and CMD to say that just run java-jar app runner from inside the container, and the application will run properly. You could do that with any other languages, basically. And then later on, Docker brought some novelty, and they introduced the multi-stage build. So for compiled languages such as Go, Java, .NET, for example, you would actually, in the first build, you would actually compile the application, and then in the second step, you would package the application in a container. In the final container. The good thing with that was that people tended to bring some build tooling inside the production image, but as you all know, the less you put in your image, the better it is. So it's this way of doing things would actually produce more lean images, I would say. So that's pretty cool. That's still totally valid to be to actually produce your Docker images this way with Docker files. That's totally perfect. And even if in some cases you might need a Docker daemon to build Docker file, well, I'm saying this, but there are some other tools such as Builder and so on that actually understand Docker files and can build without a root. But I would say that the biggest problem with that is that they don't leverage a stack specificity, in the sense that the Docker daemon doesn't have a clue that you're building Java. So it cannot do any kind of optimization related to the Java platform. And it's the same, of course, for other languages. Docker doesn't know a thing about what you're trying to do. So the cool thing was that in the Java space, there was a tool named Jib. I don't know if in any other languages there are something equivalent to this. Anyways, I'm just going to summarize this very quickly. Jib is a project that is coming from the Google Cloud team, and actually they implemented everything natively in Java. And what this does is actually produces Docker images for a Java project. But the very smart thing that they did is that they decided to separate the dependencies. So I'm calling here the libs, from the resources, from the classes, and from other custom files that you would add inside your image. What does that mean? It means that when you rerun your build, when you rebuild your image, if, for example, your dependencies, your libraries, they didn't change, then Jib is going to be smart enough to not rebuild this layer and will just rebuild the layer that has changed. So, for example, if you just change one line in your application code, it will just build one single layer and then rearrange the image to introduce this new layer, this updated layer, and that's about it. So it's kind of smart because it doesn't require you to actually rebuild everything on top of the change layer. So this is why we can call Jib a little bit smarter, because we just added this. They added the knowledge of what a Java app is to this tool. So that's pretty interesting. Of course, the downside is that it's only available to Java, and maybe some other languages have something similar. I haven't heard about it though. Let's go to Buildpacks now. So what are they? I'm pretty sure you've already heard about Buildpacks, if not from using Heroku or Cloud Foundry, because they've been around for 9 years now. Back in 2012, they were introduced as part of Heroku. You remember Heroku, or maybe you're still using Heroku, right? So you just git push your code, and then magically Heroku will spin up a dyno, and this dyno will run your code. How did they manage to do this? Well, basically they receive the code, they run some inspection, then they build your code if it's required, if you need it to be built, and then they're just going to spin up a dyno. Maybe also you've heard about Buildpacks because you're coming to the CNCF Eastern Canada frequently, and you have heard about the different stages of its acceptance in CNCF. Yes, Buildpacks is a project that was accepted in CNCF Sandbox 3 years ago, and thanks to contributions and also usage, they were actually accepted into CNCF incubation 6 months ago. So, of course, the next step of a CNCF Buildpack, if there is a tremendous success, they would go to graduated. That would be the third and last step. Anyways, what are Buildpacks? They are basically a specification and the combination of several concepts, such as there is a life cycle, there are builders, there are Buildpacks, and there are stacks. Also, when you're talking about CNCF Buildpacks, usually you will hear about a tool that is named Pack, P-A-C-K. You can get it through Brew if you're on a Mac, directly from the snap, I guess, from Ubuntu. Anyways, it's a CLI. The CLI, the Pack CLI, is the most common tooling used to interact with Buildpacks. So we'll see about other integrations later in this presentation, but this is definitely the main tool to use to start using Buildpacks. Let's go back very quickly to the concepts. And for that, I have this diagram that is showing up a simplified high-level view of what are Buildpacks, of the different concepts and how they interact together. Let's start with the bottom, with this reddish box that I called stack. In a stack, you defined run images and build images. I mean, at least one. As the name implies, a build image will be used to actually build your project, to build the image. And then the run image will be used as the base image of your production image. Then those stacks are being depended upon by builders and Buildpacks. Buildpacks, you can have several of them as part of one builder. In a Buildpack, in each and every Buildpack, you will find two scripts, or they can be executables as well, but it doesn't matter. bin/detect and bin/build. The bin/detect binary will actually try to find out if the Buildpack can participate in a given build. And then bin/build will do the work. Then on the left side, you see that I got a builder defined. This builder here in this example is composed of 3 build packs and is relying on one single stack. What does that mean? It means that this builder can actually use build pack A, build pack B, and build pack C, probably using an order. So that means that if build pack A knows how to build a node application, it will probably participate in a build when there is a package.json in the current folder. And if build pack B is a build pack that is being used to compile Java, maybe it's going to detect for a pom.xml or build.gradle file, and then we'll be able to participate in a Java build. Okay, I know maybe it sounds a little bit weird, so let's go for an example and a demo. And by the way, the demo are on GitHub. I will share the link on the CNCF Slack. So let's start from this little project. In this little project, I have defined a stack that is named Anthony. And in this stack, I've got a base image definition. Basically, it's coming from Debian 10. It's adding a few things, not super interesting. But this base image is being used by my build image. And this build image is inheriting from my base image. And is adding some tooling, some build tooling, such as Git and wget. I could have put whatever I wanted to. And also, it's very importantly defining a label. And this label will be the label that will identify my stack. Same thing here for the run image. Sorry, for the run image, it's also inheriting from the base image, but this time it doesn't add any of the tooling because we want, of course, the run image to be lean, right? We don't want to pollute it with build tooling. So if I want to build them all, they're just, classic Docker builds. So far, so good. So I would just, just build them all. And once they are all built, basically, my stack is ready to be used. So of course, my stack is going to be used by Buildpack. And here in this example, I have defined 3 build packs that I'm going to describe. First, the Hello Anthony build pack. So in this build pack, of course, you would expect to see a detect and a build script. But this build pack is pretty interesting because the only thing it does during detect is that it returns an exit code that is different from 0, meaning that it will never participate in any build. So this one is definitely for demo purpose. The interesting thing to see with the build pack is that they got also some metadata, and the metadata is expressed using TOML file. In the TOML file, you will specify your build pack API, and also some information such as the ID, version, and very importantly, the stack that is going to rely on. I have recently learned that you can use star as a stack, meaning that you would say that your build pack can work with whatever build or run image. That could be pretty interesting in some cases. Let's go to a more interesting build pack, Hello Anthony after. This one is always going to return exit 0. And thanks to that, it will always be available for a build. Let's have a look at the build. Here I am outputting some information. And more importantly, I am specifying that when the image built from this build pack will run, we will just display salut after. Okay. Then for the build pack metadata, nothing to see here. It's very similar to the other one. Let's go to a more ambitious build pack because right now they're not super interesting, right? To the single HTML page build pack. This one is going to detect, is going to look for HTML files, right? So it's basically checking if there is an HTML file in the current folder. If there is one, it's going to return exit 0. So it means it's going to participate in the build. Otherwise, it's going to exit with an error code, with an exit code. And what does it do during the build? Well, you know what? It's a poor man or poor developer web server is going to download Socat And thanks to Socket, it's going to run Socket and just pipe the content of the HTML file to Socket to port 8080, right? So it's basically a web server. So once I got those built, so I got a stack, I got some Buildpacks, and now to make the glue, to glue everything together, I will need to define a builder. So a builder also has some metadata. And in the metadata of the builder, you define all the Buildpacks that are going to contribute to the builder, right? And once they are all defined, you can also define an order, so that when you're going to use this builder, it will use the Buildpack in a given order. Okay, and finally, of course, you remember a builder also requires a stack. And this is the stack that I'm using. So let's build the builder. That sounds better. Build the builder. Okay, so I'm going to build the builder. So of course, I have already previously built my Buildpacks and my stack. So the builder is just going to reuse everything and package them all together. And then I can run my builder. And here I am running my builder in a folder with just two files, readme.md and builder.toml. If you have followed through the presentation, you know that part of my free builders, among the free Buildpacks of my builder, there are no Buildpacks that do anything with those files. But if you remember correctly, there is the hello Anthony after Buildpack that will always participate in the build. And in this case, it will just display. Remember, the funny output, right? So if you go to this one, it should actually work, right? Because during the detection phase, it's always participating. So let's run image. And without any surprises, we just got the output salue after. Of course, we could have looked a little bit more at the detail of the execution of the Buildpack. As you could see, during the detection phase, there was an error with hello Anthony because it always returned an error code, the error code number 2. And here you can see that hello Anthony after was actually picked successfully. And we can see here the output of the usage of this Buildpack. Then, on the other hand, if you go to another folder, if I just cd into a folder where there is an HTML page, and I rerun exactly the same command, so this time things are going to be different, right? Because remember, I have one Buildpack that detects HTML pages and that will want to do something with them. And this is what happened. Just using the exact same builder, but with a different context, another Buildpack decided to play a part in this build, and this is the simple web. I suggest that we just run it. So since it's a web application, I need to bind port 8080. And if I go there to 8080, welcome to Simple HTML app. It's working as predicted, right? So now, you may think, well, there are so many concepts, so many concepts to do. It looks like a complicated technology. Well, it can look that way, but most of the time, something like 98% of the time, you will be reusing existing Buildpacks. And the only thing that you would do with those Buildpacks is that you will want to just customize some action. For example, you may want to add a different JVM vendor if you're building a Java application, or you may want to add your own CA certificates, or you may want to do, just like Ricardo did during his presentation, maybe you want to insert an agent during the build. So there are some existing Buildpacks, and let's have a look actually at what that looks like. Just use the pack CLI and just ask it to build. The first thing that pack is going to reply to you is going to tell you, well, you didn't specify a builder this time. But I can suggest you few builders that exist and that are pretty popular. There is the Google builder, there are 2 Heroku builders, and there are 3 Paketo Buildpacks builders. So the Paketo builders are actually coming from Cloud Foundry/VMware. Of course, you may imagine that Google and Heroku would be excellent builders if you wanted to deploy to their own PaaS, to their own platform as a service. And then, of course, you would imagine that the Paketo Buildpacks are more focusing on probably more diverse build context. Let's go through a real use case instead of just displaying some text or piping some HTML file. I've got the example here of a Java application once again. And here, let's have a look at we can build this. So here for this Java application, I will cd to the right folder, and then I will run this command. So in this command, I'm just basically asking Pack to use the builder named Paketo Buildpacks to build my application. And this is what it's going to do. Of course, same thing here. Once the builder is downloaded, it will run through the detection phases and we'll see if there are some build packs that can participate in this build. And since it's a Java project with a pom.xml file, this builder has decided that all those 7 build packs can participate in the build. And once they've run this, they will download the JVM. Sorry, they will first compile the application, then download the JVM, but it's in cache, so this is why you're not seeing it, and then make the application available. So I guess that if I run the application like this, once again, that should work properly. So here, I guess let's see my Java application is starting. And if I go back to localhost 8080, not working. Should have worked. So maybe I just need something with the. Oh, sorry. See, I didn't map my port 8080. Okay, but anyway, the interesting thing with the Paketo Buildpacks is that they support, the Paketo builders is that they support more use cases. Bonjour, monde. Okay, great. My application is working. And when I'm saying that they support more use cases is that what you can do using the Pack CLI is that you can ask to inspect a builder. So if I do Pack builder inspect, and I'm talking about this builder, I can get some information about it. Inspect, sorry for the typo. So as you can see, there are many tooling. There are many build packs that are associated with this builder. So using this builder, we could build something else than Java application. And this is what I did in this. Where did I did that? Here I created a node folder. And if I cd into this node folder, and I rerun once again the exact same invocation to build the application. So here I'm using Pack build my app using this builder. This time, of course, is going to be a whole different story, right? Because it will notice that there is a package.json file, and then it will decide to use npm tooling, right? So far so good. Sorry, I'm not reading the comments, so I will have to guess after doing the question. Also, there are some, so you'll be able to have a look at my repo. What I said earlier on is that you can customize what they call the bindings. So you can provide your own CA certificate, your own agent, and so on and so forth. There's also an integration from Spring Boot. So Spring Boot recently, so it's a very popular Java framework. They added support for the build packs. So directly from the comfort of a developer MVN clean package, for example, the build pack will kick in. So they don't need to use the pack CLI because Spring Boot is supporting since for a year. They've been supporting the Buildpacks specification, and by default they will go with Bytecode Buildpacks. But there's nothing preventing you from using Heroku or Google Cloud Buildpacks. Something super cool. They have the killer features. The killer features. At least this one, this feature is pretty interesting. It's the rebase command from pack. Thanks to that, imagine that you have a bunch of images that have been produced using Buildpacks, and you just find out that the run images they have some security flaws inside of them, so you need to rebuild your image, right? But the cool thing with the pack CLI is that a little bit similar to Jib, you can only just intervert the parent image with the parent image with parent/run image that has no security flaws, and then reship your application. I can even go through a very quick demo of that. For example, here, if you go there, if you do a pack rebase, that I just built.
Do you think we have how many more minutes? Just I'm trying to see, if we can.
Tell me. I'm just gonna. Yeah. If you tell me I just have 3 minutes, I will.
Yeah. Let's ramp up in 3 minutes. Just because we want to make sure give people time to.
Yeah. Sure.
Yeah, but it's so far so great. The demos are working fantastic.
Nice. All right, so with a rebase image, you could actually rebase to the latest version of a good parent image. Now, to finish, to quickly wrap up, so this is a Spring application. There are many other integrations, such as Waypoint, GitHub Actions, CircleCI, Tekton, Scaffold, Kpack. Of course, the platform as a service, they have their own integrations. That's definitely expected. For example, here, if you go to my repo, you'll be able to see the GitHub Actions integration. So this is where I would just rely on this official Buildpack action to set up my Buildpack and then run it. Also, if I had time, if I had a little bit more time, I would talk about the Waypoint, HashiCorp Waypoint integration. HashiCorp Waypoint is a tool to actually build, deploy, and also direct service to your application using Kubernetes or any other deployment tool. And they actually support Buildpacks too for the build phase, as you can see. And the cool thing is that, of course, if you have spent time creating your own builder, then the cool thing is that you can use it from all those integrations. That's definitely the base. So you have your stack, or maybe you're using an existing stack, or maybe you have just created your Buildpack and then you want to create your own builder. I mean, everything is, what I mean to say is that you can integrate wherever you want. You don't have to go through the pain of creating your custom stacks, builders, and Buildpacks. You can have just your own Buildpacks and then publish it. So this is also something that I wanted to show quickly, is that the same way that we have Docker Hub, mHub, there is also a registry or a registry for Buildpacks, and you could definitely create your Buildpack and then publish it to this registry. It's linked basically to your GitHub account. So for example, here, if I want to use this Buildpack, they will give me instructions on how to use it, right? So for example, if I want to deploy to Azure, maybe I want to use this Java Azure Buildpack. Okay, and yeah, sorry, Java Azure is this one. And finally, last words. Our Buildpacks the right tool for you, right? So I owe this answer to you guys. Should you go ahead and use Buildpacks? I'm gonna say that try to stay pragmatic. If it's just one single app, or if you're comfortable with Dockerfiles, just keep on using them. Yay, they're good. Just make sure that you follow the best practices, of course. Now, if you run a PaaS such as Google Cloud Foundry or Heroku, of course you will want to use Buildpack, right? Because they allow you to run all kinds of projects. But if you're not a PaaS, and if you are like me, in an organization where you have several teams building projects based on Java or Node or even Python, then you would want to invest some time into Buildpacks, because using one builder, you could actually have a unified way of building the images across your organization, and also to enforce things such as inclusion of CSRT agents and whatnot, because you own the build phase. That's about it for today. Sorry if I'm late. Sorry for the confusion.
No, fantastic, Anthony. It's been a very interesting topic, because I think a lot of people were interested to hear about it. And you know, Buildpacks has been recently incubated, right? So we wanted to share the story about it, and it was great to learn that, you know, it's been used by Cloud Foundry previously and Heroku, and it would have been nice if we have some kind of a nice PaaS maybe on top of Kubernetes one day that is open source and everybody can use to simplify their deployments and building you know, container images. So I think Buildpacks will be important component of this.
I'm counting on you for this, Archie. I'm counting on you, Google, and Tecton to achieve everything, right?
I don't know. For me, as far as it should be open and everybody can use it, you know, not very opinionated, that would be great. So, okay, we're going to go say thanks to Anthony, and we're going to do quickly the draw.
There's just one question left in the Q&A. I don't know if Anthony
Sure. I'm just going to put the slide.
Yeah, or maybe Ricardo, you guys can go look there. Yeah, it'd be great if everybody could fill out the survey, but if there's one question there from Roy.
Yeah, I can take it. So Roy is asking specifically for the multi-stage Docker builds. So that was the one of the first way that I experienced during this presentation. Using JLink, which is okay since JLink N9, unless you want to bring over the entire. Okay, so Roy is talking about a specific to Java way of building your images, where you can actually end up with one single binary using JLink, but that is a very recent addition to the Java platform. So to answer you, yes, I mean, if your question is about how would you integrate Buildpacks and JLink, that's definitely possible, because once again, if you create a Buildpack, or maybe if you reuse a Buildpack but knows how to interact with JLink, well, why not? Sure, it could definitely just compile your application, adding the necessary modules, the necessary Java modules to actually have a single binary application. The same thing goes also for native Java builds. For example, in the Spring Boot project, they support using just a single environment variable that you could, they support the fact that you want to export your Java application not as a jar, but as a single binary file using GraalVM. So what I mean to say is that just have a look at the different Buildpacks that exist out in the wild, and there are probably Buildpacks that are already doing what you expect, what you would want to do with JLink.
Awesome.
Thanks, Anthony.
So let me just make a quick draw so we get the winners. Can you see my screen?
Yes.
And as I said, we're thanking JFrog for sponsoring this draw today. So we'll have 5 winners who will get books and a T-shirt at the same time. So I'm going to go. I think that's it. Oh, we have 2 more people who just joined. So that's great. We'll make sure everybody's included. Oh, okay. I think I got the small. Okay, hopefully everybody's here. And let's do the first winner. Julia, can you take the names? Because I don't have a second screen right now.
Sure.
All right, first winner is Armand. Congratulations.
Hold on.
Yeah.
Okay.
All right. Second winner, Safa Bayar. Congratulations.
Good.
Eric was very close. I think he was winner of the previous event. So.
All good.
And we have Gustavo, my friend Gustavo from Brazil. Yeah. Hi, Gustavo. Nice to see you here at the event. And then the fourth winner is Sergey Vlasov. Поздравляю. Okay, the last winner for today is Sufyan. Congrats. All right, thank you so much, everybody. Sticking all the way till the last minutes of the event. We want to finish our April CNCF Canadian meetup, and we're looking forward for May event. Don't forget to join KubeCon next week, and then you'll probably see us there as well. So we're looking forward for the next event together. Thank you so much for staying.
Thanks, big shout out to Ricardo and to Anthony for being here. Thank you, Elastic, also for sponsoring us. Appreciate it.
And we're sharing the stuff in the Slack channel, and the video will be available at the event page itself.
YouTube.
Thank you so much.
Bye.
Bye.
Bye. Thanks, guys.